Hello everyone, today we will be multiplying matrices, but in the context of worded problems. Okay, so for our first example, we're talking about an AFL game. So this week's AFL results have been posted in the table below. So we've got three teams, the East Coast Falcons, the Free Cloak Wolfers, and the Portside Chihuahuas. And here are the goals and the behinds that they scored. So, if a goal is worth 6 points and a behind is worth 1 point, use matrix multiplication to identify which team scored the most total points. So we have to use matrix multiplication, and the goal is to work out which team scored the most total points. If we look at the table that we've been given, it's already set up in quite a nice way. So I want to make a matrix that kind of reflects what I see in the table. So I'm just going to take the elements that are already there and arrange them in the same way. So I'll get a nice 3x2 matrix, and let's call this R. So when I look closely at R, I can see that this is a 3x2 matrix. So keeping in mind that a goal is worth 6 points and a behind is worth 1 point, I need to make another matrix that will multiply with this 3x2. So looking at all the options I have, I could either have a 1x2 matrix written like this, or I could have a 2x1 matrix written like this. So which one should I use to multiply with the table above? Well, let's see what works. So if I take the first matrix and I move it up here, if we just look closely at the inside values here, we got a 2 and a 3, and we can see that those will not multiply together because they are not the same number. So I know for a fact I cannot multiply with this one in the front. So what if I moved it to the right though? Maybe it will work over there. Okay, so I've moved it over to the right and we can see we have the same problem. We got a 2 and a 1, they're not the same numbers. So I can't multiply there either. So what this means, unfortunately, that this matrix is not the one I'm going to use for the problem. So I've decided to try to move the other matrix up to the top. Again, just checking 1 and 3. This is not going to work, but let's try on the other side. So we've moved the matrix across, and we can see that finally the inside numbers match, which means we will get an answer if we multiply this way. And not only will they match, we will get a 3x1 answer. So we're going to end up with a 3x1 matrix, which is good. Okay, so I've set up my table like this with the first matrix here, and I've raised my second matrix up. And this is going to give us a nice 3x1 answer. So let's start working this out. So we're going to times the first row with the first column. So we're going to go 8 times 6 plus 14 times 1, and that gives us an answer of 62, which we write where these two line up. The next thing I'm going to do is multiply the second row with the first column. So second row with the first column is 11 times 6 plus 5 times 1, which gives us 71. And finally, the next thing I want to do is the third row with the first column. So 6 by 6 plus 21 times 1 gives us a total of 57. Now we want to keep things nice and professional, so we'll be given a worded question. So it'd be nice if we can give a worded answer. So to summarize what our matrix says, the East Coast Falcons scored 62 points, the Free Cloak Wolfers scored 71 points, and the Portside Chihuahuas scored 57 points. So overall, we've described what we've seen in the matrix, and we can see that the Free Cloak Wolfers were the highest scorers overall. So we've answered the question and shown all our working out, which is awesome. Okay, let's try another example. So, in example number 2, we've got a bakery that sells pies, hot chips, and lamingtons. The sales of each item is recorded in the table below. So we've got a table that has pies, chips, and lamingtons, and the sales that they made throughout the week, Monday, Tuesday, Wednesday, Thursday, Friday. So, the bakery sells pies for $7, chips for $5, and lamingtons for $4. So again, we're going to use matrix multiplication. We're going to work out how much money the bakery made from sales each day. So just have a think. If we're trying to work out the sales each day, our answer should have 5 somewhere in the dimensions, okay? So we need to have some sort of 5 either in a row or a column in our answer. So let's try to work out this problem. Okay, so just using information I've been given again, what's the easiest matrix I could make? Well, I could just turn this into a nice 3x5 matrix, which we'll call S. So again, I'm just using the table given and just turning that into the easiest matrix to use. So we know S is a 3 by 5 matrix. And we've got to remember that with the prices, $7, $5, and $4, we could either write them vertically as a 3 by 1, or we could write them horizontally as a 1 by 3. Now, only one of these matrices is going to be appropriate for this particular example. So let's try to work out which one works. Okay, so if we look at where the matrix are positioned now, we've got a 1 on the left and a 3 on the right. So these inside numbers, again, are not compatible with each other. Let's try at the end. So even when we move these matrices across to the right, we've got a 5 on the inside and a 3 on the inside. So no matter what, this vertical matrix is not going to be used in my solution. So let's see if the other matrix can be used to help us out. Okay, so I've moved this matrix up, and if we compare the numbers now, we've got a 3 and a 3. So the internal numbers match, which means it will multiply to something, and the outside numbers, 1 and 5, will give us a 1 by 5 answer. Now just remember what I said before, if we're trying to find the sales per day, we probably want a 5 somewhere in our dimensions. So this answer works, and it also makes sense in the context. So let's actually see what this answer will be. Okay, so I've got my matrices lined up here, and we know we're going to get a 1 by 5 answer because we can see there's one row with 5 columns, so we've got that set up. First row times the first column, 7 times 10 plus 5 times 20 plus 4 times 5 gives us 190. Now presumably that is dollars, that makes sense. 7 times pies, 5 times chips, 4 times lamingtons gives you 190. Alrighty, to save you time, I'm not going to animate the whole entire thing, but if we did the same row and column process, we'd end up with these numbers here. So these are the individual sales for the day. So 190 on Monday, 125 on Tuesday, and so on and so forth. Again, we're wanting to be as professional as possible, so even though we've got this amazing matrix here, we should really talk about what we found out. So the total sales for each day were $190 for Monday, $125 for Tuesday, $225 for Wednesday, Thursday was $190, and Friday was $330. Alright everyone, thanks so much for watching. Hopefully that makes a little more sense about matrices. If you have any questions, please leave a comment and I'll do my best to help you out. Apart from that, hope you have an awesome day.